Today we're going to talk about double factorials and how we can write them in terms of single factorial. So first we'll go over the definition. You have a definition for n double factorial when n is even and another one when n is odd. They're pretty much the same definition. N double factorial, well, you start at n, and this time you keep multiplying by 2 less. N minus 2 times n minus 4. And if n is even and you keep taking away 2 from it, eventually you'll get to 6 times 4 times 2. Once you hit 2, you stop. If n is odd, it's the same game. It's n times 2 less than n times 2 less than that. Now if n is odd, you keep taking away 2 from it, these numbers, these factors will stay odd. So eventually you'll get up to or down to 5 times 3. And whatever this is, if you multiply it by 1, it doesn't change. That is, you can stop at 3 when it's odd, or you can stop at 1. Now, you don't even really have to take notice of whether n is odd or even. Just stop at 2 or 1. Only one of them is going to come up, and you stop there. So, for example, 8 double factorial will be 8 times 6 times 4 times 2. And 10 double factorial will be 10 times 8 times 6 times 4 times 2. And 7 double factorial will be 7 times 5 times 3 times 1. And 5 double factorial would be 5 times 3, which is 15, times 1 is still 15. Now, I know what this is. I just did it. It's 15. Well, 7 times 15 is 105. For 8 factorial, we have 8 times 8, which is 64. And we need to multiply that 64 by 6. So we get 360 plus 24. 360, 370, 380, plus 4 more is 384. We get 384. Now, 10 double factorial is 10 times what I just boxed. But what I just boxed is 384. So this is going to be 384. Okay. So now, let's look at how we might write these with single factorials. Okay, actually, we don't need any of this. Let's see how we might write this with single factorials. Let's look at 8 double factorial. It's 8 times 6 times 4 times 2. Now, 8 is 4 times 2. And 6 is 3 times 2. And the 4, that's 2 times 2. And the last 2, why, that's 2 times 1. So, turns out what's in red, okay, and this last 2, we can think of as 1 times 2, excuse me. So, what's underlined in red, what's in red, is simply 4 times 3 times 2, which is 4 factorial, times a number of 2's being multiplied together, namely 1, 2, 3, 4. So that's 8 double factorial. It's 4 factorial times 2 to the 4. Now, what would 10 factorial be? Well, that's 10 times 8 times 6 times 4 times 2. But this here is 8 factorial. So it, sorry, 8 double factorial. So it's 10 times 8 double factorial. But 8 double factorial is right here. It's 4 factorial times 2 to the 4th. Now, we're going to rewrite this a little bit differently. 10 is 5 times 2 times 4 factorial times 2 to the 4th. But the way I multiply 1, 2, 3, 4 factors is up to me. I want to multiply the 5 with the 4 factorial. I want to multiply the 2 with the 2 to the 4th, and then multiply that together. Thing is, this is 5 factorial. Meaning it's 5 times 4 factorial, which is 4, 3, 2, 1. So here, so this is 5 factorial. Times 2 times 2 to the 4th is 2 to the 5th. So what we have is, and I'm going to write it right here, please. We just learned that 10 factorial is 5 factorial times 2 to the 5th. So the question is, do we see a pattern with 10 factorial and 8 factorial? Well, the first thing I'll notice is what I'm taking the factorial of and the power of the 2 are always the same. The next thing I'll notice is that if you take half of this number, you get the 4. That's how you got the 4. How did we get the 5? We took half of that number. So if n is even, I maintain that n double factorial, well, it'll be n over 2 factorial times 2 raised to n over 2. So that's the formula for n double factorial in terms of single factorial. Now, let's try to do the same exact thing for odd values. If you have 7 double factorial, which is 7 times 5 times 3 times 1, you could multiply the top by 8 and 6 and 4 and 2 as long as you divide by that. Now, the top is nothing more than 8 factorial. And the bottom, surprisingly enough, is a double factorial. But 8 is even. So I can use the rule that we have down here for 8 double factorial. It's half of that is half of this number factorial times 2 raised to that number. Okay, and that's the rule for 7 factorial, 7 double factorial, excuse me. If we look at 5 double factorial, well, that's 5 times 3 times 1. Well, I'll put in 6 and 4 and 2, and then I'll divide by 6 times 4 times 2. Well, the top is now 6 factorial, but the bottom is 6 double factorial. The 6 is even, so I just take half of it. Get 3. 3 factorial, 2 to the 3. So now the thing is, if n is odd, do we see a pattern? For example, how do we go from 7 to 8? The answer, and from 5 to 6. The answer is we add 1 factorial. And in the bottom, if this is 6, you put half of 6 here and here. When it was 8, we put half of 8 here, and the 8 over 2 was just supposed to be 4, but then it was 8. We put 4 here and here, half of 8. So I take half of this, n plus 1, which is n plus 1 over 2, factorial, times 2 to that same number, n plus 1 over 2. And here's the formula we use when n is odd. So now we have a nice formula for n equals an even and for when n is odd. The n factorial, when n is even, is just n half factorial times 2 to the n over 2. And if n is odd, it's n plus 1 factorial divided by half of n plus 1 all factorial times 2 to the n plus 1 over 2. And we can verify this for a couple of numbers. Let's make sure that we're not just making up this stuff. So 5 double factorial is 5 times 3 times 1, which is 15. So since n is odd, we claim that this is going to be 1 more than n, and then half of that number factorial times 2 to that number. Well, this is going to be 6 times 5 times 4, and 2 cubed is 8. Well, 4 goes into the 8 2 times, and 2 goes into the 6 3 times. We're left with 3 times 5, or 15. It did work. Let us try with an even number. Suppose we have 6 double factorial. This is 6 times 4 times 2. That's 8. 6 times 8 is 48. So the question is our formula going to work? It says take half of n is 6. Take half of it, factorial, and then multiply it by 2 to that same number you took the factorial of. And this works like a charm, because 3 times 2 is 6, just like this was 6, times 2 cubed, which is 8, which is exactly what 4 times 2 is. So yes, we do get 48. So the formula works for those two cases, for those two examples, and they work in general. So there's a nice way of expressing n double factorial in terms of single factorial, either when n is even or n is odd. And that's basically it for this video. If you like these type of math videos, please subscribe to my channel. We have lots more to come.